Let's get started. Anyone wants to share anything for what they've done, or we could go right into the coding session. I think it's 4 of us. Perhaps, we can just have 2 breakout rooms. Gotham and I and Darren Ure can be in the same room, and then we'll dive right into it. I think I presume no one has done much during the Thanksgiving week. I assume. Correct me if I'm wrong. If you went full parabolic on this, but that's my presumption.
Yeah, I started working more with simple transformers.
Okay.
Because of Parth, and it was really interesting for me. I didn't produce any great numbers yet, but I learned a bunch of things about, I guess, deep learning practices I didn't quite understand before.
Nice. What kind of deep learning practices do you want to share?
Well, they were sort of simple things, I guess, but I guess the idea of early stopping and how different it. Like in non-deep learning, even when it was context-free stuff with WordDev, you were just doing hyperparameter tuning, and you'd run with different epochs and different things. There was no early stopping, I don't think.
Yeah.
But with deep learning models, I think first of all, because they're huge and they can take forever, and not for us probably, but they are big, that you needed something to checkpoints. So they sort of go hand in hand, checkpoints and early stopping. And I wasn't really totally familiar with those two ideas before. And so are you guys? Have you used any of you guys used checkpoints or early stopping?
Yeah, there's callbacks. I think it's part of the callback that you can do with Keras and of course Fast AI as well. Yeah, it's part of the callback.
And what did you use it for? What did you use checkpoints for?
I think I believe it was like every checkpoint for the highest accuracy or something like that, and you save that model. Basically, when you performance, then you save it. Yeah.
So you did the best. That's part of the checkpoint functionality. Best model. You can set it, save the best model. That's what you
exactly.
Yeah. So anyone else? Anyone else have experience using checkpointing for anything?
No, but actually, since you mentioned simple transformers, I've seen them before, but I haven't really used them. What's the main advantage? Is that a wrapper or?
You're talking about checkpointing?
No, you mentioned simple transformers, didn't you?
Oh yeah. The main advantage is it's just you don't have to deal with layers and pooling and setting up the how you have to encode your inputs like 3 times with padding and all that stuff. It makes it's just a very straightforward, easy to use way you can use models, and you can use any of the transformer models. I can show you a little bit if you want. If you're already good with the transformers independently, this may not be useful for you, but for me, it's a great way into sort of the discipline in a way, instead of from a model architecture point of view, from a practices point of view. Did you want me to share?
Sure.
Okay.
But I didn't want to, if you want to do something else, I can.
Yeah, I don't know what you guys want to do. Do we want to split off, or do you want me to keep going over my learnings with simple
I would love to see it as well before we jump into the breakout room.
Okay.
Yeah.
Share screen.
Thank you.
See what I can show. Some of it I can't because it's Colab, and the models it generates have disappeared now, of course, because I didn't want to save them because I'm not ready for that yet. But Okay, so let's do this. I'm assuming you guys can see my screen.
Yep.
I guess perhaps simple transformers. Here they are, just so you could see. You know, this is the simple transformers documentation, and these are the tasks that they have built in sort of support for, like they subclass their stuff. Okay, so you can see I'm doing the question answer. That's what I'm doing. So I have a framework you use, and then some of it is specialized, like the data input's different for each one of these. And the other thing that's interesting, which I'm learning and working my way through, is this part, this tips and tricks. And so they'll have using early stopping. That's what I can't get it. I haven't been able to get it to work yet. And how to add additional evaluation metrics through a callback. And they actually have a Streamlit viewer that if you get your model trained, you then have a little demo, I think, where you could just run this Streamlit application, and it gives you a web-based application where people can manually put in, input and test it, which is kind of fun. And then there's hyperparameter optimization, so I'm going to see what that's like too. And I'm just working my way down through these, and I don't know what this part is, the custom parameter groups. Okay. So very simply, you here's your args. See model args. It's an object. This is one way you can configure your arguments. And down here, I'm configuring. This is just cut and paste from them. I don't think I adjusted any of these. And then these are the arguments I did with. You can see they're all evaluate during training, and what that means is you need to provide a holdout set. Okay, so I take the tweet extract and I pull out a certain percentage of those randomly, and use those so you don't train on it. That's 5,000 of the entries I use, and these are just some configurations that tell you. It tells you to do the, if you set this to true right here, after each epoch, it will run an evaluation. Like it'll run the epoch, the training, and then it'll run your evaluation, and it saves it for you too. It saves it to an output directory. And so I can see where I am with the Jacquard score because I'm actually using the Jacquard metric. And then here, steps, I put it high, but what you can do with the steps, training steps, I had to learn what training steps are, right? That's how ignorant I was. But the training steps, basically, you can see there's a mini batch default. You can set your mini batch. So here your mini batches are 8. And then I read a bunch about mini batches and why they do it and all that stuff. And this is telling you how many mini batches to run before you run an evaluation. So the thing is, we don't have a huge number of items, right, that we're training with. It's like 20,000. But if you're dealing millions and millions, you may not wait till the end of you may not want to wait till the end of the epoch to get an evaluation and save an evaluation. So you could set this to like 1,000 or whatever you wanted. So you do an evaluation at each step. So it's sort of like enabling sub-epoch evaluation. And one of the reasons for getting these evaluations after the epoch or sub-epoch is so that you can afterwards, I guess you could chart it or diagram it and then see where your evaluation, which is on your holdout set, starts diverging from your evaluation on your training set, which is done automatically. And of course, that's where you start overfitting. And so that's your point. You probably want to, stop training. And that's how you use early stopping too, supposedly, is you wait for it to diverge and then you just stop it. And then just to show you guys real quickly, here's the, I instantiate the model, and I'm instantiating the subclass, the question-answer version, and it's Distilbert, and you can use a path or a name. And see this name here? These all come from transformers. So you can use any transformer model by name. And you're feeding your arguments into it here. And then here's where you just train it right here, okay? And here's the little trick. See, Jacquard, if you put any keyword args in here like this, it's going to use my function. Higher up, I have our Jacquard score from the competition. It's just a simple function, right? And that means, what that Jacquard score means in there is, along with the other stuff, is that, what are we doing here? So here is our, so you see it starts training, and then when the epoch's done, I did 5 epochs, but you see how that's 5,496 documents it's processing. So this is the evaluation. It doesn't show you the results. Then it does another epoch, and then it does another evaluation using Jacquard on the holdout set, so forth. And I got some kind of error, I don't know. But then here's the results. It spits out. So I do have a question for everybody about this. I was hoping you guys could help me with. Are there any questions about what I did before I ask everyone a question? You guys still alive? Did I lose everybody?
Yeah, we can hear you. I don't have any questions.
Okay. Okay. So this is what I can't quite understand. So this, I could figure out from the documentation that this eval loss, I know, of course, this isn't Jacquard. Jacquard's down here, but is a cross entropy. But then there's this training loss, which, and I can't figure out the difference. And this training loss always looks more normal. See how it's, close to 1 or whatever, and it's going down. But then this eval loss, which I think happens with every, I don't know what it is, with every epoch, right? Because these are 5 epochs. I guess it's true. It's always giving me this really large negative number. I don't understand it. Does anyone have experience with cross entropy and getting large negative numbers?
Could it be your validation sets loss?
No, is that what you're thinking? That this could be the training set loss?
Yeah.
Which makes sense because it's much better, right, than the evaluation loss. It could be that simple.
Yeah.
I think you're probably right. Yeah. And I could know if I did not, so up here, I could test that out, of course, by going up here and running this whole thing without, see how I had to put the evaluation set in there?
Mm-hmm.
When I run the training. If that's not in there, it's not going to probably produce that eval loss, and that would be full confirmation, right, that what you're saying is true. So that makes sense. And my Jacquard, there's my Jacquard. So not great, but, it's something it's a pretty good baseline to start with, I guess.
Yeah.
Did it actually train?
Oh, yeah.
Doesn't look like it changed that much, right?
Isn't it weird? It's kind of weird. Unless you look at the training loss, though, that's pretty intense, right, Yuri?
Okay. Oh, okay.
Right. So why do you say it doesn't look like for the Jacquard it did shit, right? Look at that. Jacquard just went up 1 on the second epoch and then down. Is that what you were referring to?
Yeah, it looked like it's basically stayed the same.
Yeah,
The
it's
score
crazy.
again. We know that score is not a good loss, probably.
Well, you also can see here they have these very simple metrics for how many I got correct, and you see that gets better. See how up here? Oh, it gets worse. So the number of correct actually seems to be dropping. The number of incorrect is...
That's why your Jacquard score is dropping too, right?
Yeah, but what you'll see is the similarity one is going up. So things seem to be going into the similarity space. So it seems like the model's a little confused, huh?
Okay.
So, they explain what similarity is. Those metrics, correct, incorrect, and similarity are QA model specific, and they're very straightforward. I think they do some sort of, it's not Jacquard, it's much simpler.
Mm-hmm.
Sort of similarity metric between your tokens. So, yeah, something's acting a little funny with the model, I would agree.
Yeah.
And I got another question, though. Why this one's always going up? Does that make any sense, that the eval loss, it seems like it's just getting worse? Well, let me put it this way: is a larger negative number better or worse with cross entropy? I have no idea.
I think cross entropy cannot be negative, right?
Well, I researched it, and people do get negatives, but I couldn't understand why, and it seemed like it might be a bad thing. So down here, it's using the same evaluation metric for the training set as it is for the evaluation set.
I think cross entropy is negative. Then you put a negative sign ahead of it, then it's usually positive. Then you minimize the positive number, and that's what it is.
So you think my loss is going up in effect? I should just ignore that it's negative and just say, oh, it's going up, which is really bad for my evaluation set.
Yeah, I think there's something wrong with this evaluation loss. What? Sorry, can you scroll up and let's see the loss metrics? Are you inputted?
The loss metrics that I inputted. You mean well, I didn't. They're default.
Okay.
So I didn't configure them. I think.
Yeah. Perhaps.
Yeah. So it explains the ones you can use. So and one of them is just the here. Okay. So let's look at here's the QA. I'm going to look at the QA stuff for this simple. Okay, they're just showing you stuff here. Lazy loading, I have to worry about that. What the heck? Okay. Here's where most of the info is, I think. So this is telling you how to instantiate it. Some configurations. It's going into the class. I think that here's where it might tell us about the metrics. There you go. So here's the metrics that they provide. Okay, and that's the eval. That's what's being used. Because you see there's correct, similar, incorrect in that fourth one for the eval and for the training is a cross entropy loss.
Yep.
So something's funny, I guess.
Yeah.
I guess I need to work with it more. But it also outputs checkpoint models. It's kind of interesting to see all that. But I need to get this working better, I guess. Something's funny.
So is this, I guess, is this supposed to be a little easier than perhaps, Hugging Face transformers?
Oh yeah, it's a lot easier. You don't have to deal with any layers or anything. I mean, really, it's quite simple, and they have all these things on top of it that make it easy to do hyperparameter tuning and all of that. But I mean, if I can't get the model working, well, who cares, right?
Right. Too simple.
Well, I mean, it's working okay. I mean, those aren't horrible Chagard scores. It's just it's a little I'm uncertain what's going on here. So.
Yeah, it seems like the training process is getting a little.
Yeah, I mean, it was yeah. Anyway, it's good to be able to use a holdout set and use a card on it. But you could do that with Keras, of course, but not with. I couldn't figure out how to do that with Spacey. Well, there's probably a way.
Okay, great. Thanks for sharing. So let's move into breakout room. Darren, you're with Yuri. Is that fine?
Yeah, because Yuri doesn't mind. I just shared everything I got. So that's fine.
Okay. Darren, I'll talk to Gotham and Shamsuddin, Dinesh.
You can put me. Actually, I'm attending. I'm not sure about the competition, so you're gonna probably keep me out because I won't be any helpful for anybody.
Okay. Shamsuddin, you? Are you here, Shamsuddin? Okay. Doesn't seem like Shamsuddin is here, so maybe I will not assign a room for you guys. You guys can stay in the main room
Sure.
if you and we will return around 12:15 as always. And here we go. You guys, what's going on? Gotham had to leave because of the homework review session. Oh, it's just you, Darren. Cool. I don't have too much else to update besides going further on the spacey model. I'm still trying to solve the bug that I had, and just like keep digging into this model. Oh, here's Uri. And how are you guys doing?
Good. So we didn't code anything, but we went through LIT.
Got it.
Don't know. If you guys want, we can quickly go through it. Maybe
Yeah.
we'll do it like we could do more next time if we have like results.
Yeah, I would love to see it.
Okay. So LIT, there's a recent blog post. Blog post on Google AI because they released it, I think, half a year ago, but they presented it at the conference recently, and they kind of updated results. They have a demo, so we run it like before. I had problem installing stuff, but now I just like run in the demo environment, and they have classification and regression model. So this is it. They had the model that was trained on this SST dataset. So interesting layout of the tool. We ignored attention because that didn't really give me much, but we used this like, so they have tabs here: performance, prediction, explanation. So we use this explanation tab, and you can put in, basically I put in the sentence. You can see like that's one of the few first sentences in the data set. Yeah, good for both of you. Enjoy the break. Analyze data point, and it basically has 4 different methods of analysis. The one that seemed to be good for negative examples, which we looked at initially, was Lime. But then three more methods, which I didn't look at them. Color here and the number give you positivity score. So here the answer would be, so it gives you positivity score for every word. So we talked about how to combine them together. And this is pretty interesting. This is a standard interview question. I have it like right here. It's called Cadena algorithm, finding largest sum contiguous subarray.
Right.
So it'd be really cool to implement it in real life. But yeah, so I was thinking taking Lime score. So basically so to step back, the answer I want to try is have a training, sentiment analysis model, run it on the same data set. Hopefully my answers would be very similar, and then use this interpretability tool to basically tell me which words, which segment was most important for this answer, using this Cadena algorithm. And in this case, it would be this segment from good to enjoy, which overlaps really well with the answer they have.
Nice.
So,
The Cadena need both classes. So you get, in this case, the numbers let's say the numbers that we get from Lime. Do you know, Yuri, if like yay would be like a negative number and good would be a positive number?
yeah, do you see? It comes up in the.
Oh no, I don't. Oh, there you go. Yeah. I see what you're saying. So it conforms perfectly to that algorithm.
Yeah.
Because you'll get negative.
Yeah.
Oh,
And
that's a negative number too? is good is a negative number?
No. It
Oh,
actually
okay, there you
gives
go.
me positivity. So last
Yeah,
like for
I see it.
negative answer, I was looking for most negative. For positive answer, I'm looking for most positive.
But it won't
And
be, yeah.
and as I'm like talking about it, I probably can like add to it and say like I don't know if the answer would improve if I end the segment on the sentence end.
Yeah.
You know how like enjoy the break really belongs to a different sentence.
Uh-huh.
So maybe I can like go by like the segment only the sentence pieces.
Mm-hmm.
So.
Sorry, what data set is this?
Oh, I was initially planning on training my own model, but it looks like this I can just use this as this SST2-tiny model that they use here. I couldn't find it, but I think I suspect it's a BERT tiny model trained on SST dataset.
An SST data set is?
SST is Stanford Sentiment Tool.
Oh, got it. Stanford Sentiment Tool. Okay.
But that has nothing to do with it except for that's what they're using to do the sentiment classification.
Yeah.
Right. Lit is
Stanford
you can use
Sentiment
any
Tree Bank. Yeah.
Yeah, you could use any classifier you want and still use lit on top of it. And
Yeah.
also Yuri put in a sentence. That exact sentence he was looking at is from our data set.
Yeah, so I was copying basically. I copied this from
into the box in the upper right there.
Yeah. And actually, like I'm thinking as a first attempt, I'm probably not going to use the lit, but I can just use the lime. There's a post that shows you how to use lime on NLP models, so I'll try to do that. But I haven't read this yet.
Gotcha. Cool. Very cool. This is cool. Salience map. Yeah. I gotta try this out. Very cool. Would you mind sending me a link or something?
Yeah, so
tutorial.
I think this is like a good, yeah, I'm gonna post it, but this is a good way of starting looking into lit.
Yeah, please do. Thank you. Cool. All right. On that note, I want to thank everyone for joining the session. I'll talk to you guys next Monday.
Thank you.
All right. Sounds good. Have a good one.